just we are going to discuss some concepts of OSPF, like how to change transit router. First of all, understand what is transit router and stub router in OSPF. Okay, so this is topology in front of you. Okay guys, let's say by default cost on all link. See, let me make you familiar with this topology. In the topology, you are able to see router 1 is connected with router 2, router 2 and router 3 is connected with router 4. And router 4 have some prefixes 50.1.1.0/24 to 50.1.5.0/24. Right. So I have enabled OSPF on all interfaces of all routers. Router 4 will advertise this network to router 2 and router 3. After that, router 3 will advertise it to router 1, and router 3 will also advertise it to router 1. Router 1 will receive these prefixes from two sides, from router 3 and router 2. Yes or no? And router 1 will do what? Load balancing, because from both sides metric and cost will be equal. Metric and AD value will be equal. Yes or no?
Yes.
Yes, sir.
Okay, in the form of which LSA router 1 will receive this prefix? In the form of which LSA router 1 will receive this prefix, guys?
LSA 1 if a single area is
Yes,
considered.
LSA 1 in the form of LSA 1. Right, inside the database of router 1 you will see there will be one LSA 1 of router 4, and in that LSA 1 these prefixes will be there. Okay, now let's say cost on this link is 10, cost on this link is, let's say, 5, cost on this link is, let's say, 15, and cost on this link is 10. Now router will install these prefixes in their routing table via which router? See,
R2.
via R2, because cost on loopback interface is 1 and cost over
1.
here is 5, 6 and
5.
10, 16. Total cost to reach in this network via router 2 is 16, and total cost to reach in this network via router 3 will be 26. So router 1 will install these all prefixes via router number 1. Now whenever router 1, or let's say here we have some user, these user want to, let's say, or this user, a single user, want to communicate with 50.1.1.1. so router 1 will forward traffic to router 2, and router 2 will forward traffic to router 4. So router 2 is transit router for router 1. Whenever router 1 want to reach in this network, router 2 is transit router. Transit router means the router through which your traffic will flow. Okay, so here in this scenario, when router 1 is performing load balancing, that means that time both router is transit router 2 as well as router 3, but this time only router 2 is transit router, because router 1 is forwarding all traffic to router 2. So for router 1, router 2 is my transit router, and if you want to change the transit router, so you can configure this router as stub router. Stub router. Also, you will configure this router as stub router, right? This router will be not your transit router. You know what router 2 will do? Router 2 will consider cost to reach their neighbor is 65535. Here also, to reach this neighbor also, it will set cost 65535. Once you will configure R2 as stub router, it will set cost 65535 to reach their neighbor. Then you will check the cost of this link will be 65535. Now this time from router number 1, tell me guys, what will be the cost to reach in this network via router 2? Cost is 1 over here, and this receiving interface cost is 65536. 65536, 5 plus 1, and after that cost of this receiving interface is 10. So total cost will be 65546 via router number 2, and cost via this side, lower side, is 26. So router 1 will use which path?
R3.
R3 path.
So we have one option in OSPF to change transit router, and command is very simple. Let me first enable OSPF here. I think I have already configured. You know, IP address on all router. Let me check. So IP interface brief exclude unassign. So IP interface brief exclude unassign, and you can see the IP done 12.1 and 13.1. Let me ping router 2 12.1.1.2, and you can see I think I am able to ping, yes, and ping 13.1.1.3, 13.1.1.3. See, I am able to ping both router. Let me check routing protocol. So IP protocol. So I am not running any routing protocol. Let me configure OSPF for router OSPF 1 and say router ID 1.1.1.1 exit interface range F0/0 and F1/0 IP OSPF 1 area 0. So I have enabled OSPF on router number 1. Let me enable OSPF on router 2 also. Config T and router OSPF 1 router ID 2.2.2.2 and interface range F0/0 and F1/0 IP OSPF 1 area 0. I have enabled OSPF on router number 2 also. Soon OSPF neighborship will come up. Let me take you to router number 3, and here also let me enable OSPF. So IP protocol, okay, router OSPF 1 and router ID 3.3.3.3 exit interface range F0/0 as well as F1/0 IP OSPF 1 area 0. So I have enabled OSPF on router 1, router 2, router 3. Let me enable on router number 4 also. Config T router OSPF 1 router ID 4.4.4.4 exit interface range F0/0 F1/0 and loopback 1 to loopback 5. Interface range, okay, loopback 1 to loopback 5. IP OSPF 1 area 0. I have enabled OSPF on all router. Now let me show you the routing table of router 2 or database, sorry, router 1 or database of router 1. So IP route OSPF. So you can see router 1 is receiving all 50 prefixes via router 2 as well as via router number 3, and cost to reach in this network via both sides is 3. Yes. So IP OSPF database and router LSA, you are able to see, you know, here is router LSA of router 4. Inside this LSA, these prefixes are there. If you will open database, then router and 4.4.4.4, so you can see 50.1.4.0, 50.1.5.0 all network and metric inside the LSA. This is LSA metric. This is metric which is coming in LSA, link state advertisement. After that, router 2 will add their receiving interface cost, and router 1 will also add receiving interface cost. So now it is performing load balancing. Router 1 is performing load balancing for these prefixes. Let me do one thing. Here I am going to change the cost. Here I am going to set cost what on this link 10. Here I am going to set cost, let's say 15. Here I am going to set cost what 5, and here let's say I am going to set cost 10. Done. And guys, now on router number 2, if you will run command so IPOSPF database, so IPOSPF database, and let me open router LSA and router LSA of router 2 in detail. This is command to open router LSA of router 2, and you can see the metric to reach 12.1.1.2 is 1. Metric to reach router 4 is also 1, means to neighbor. You know, here I am using link what Ethernet link. If I will use serial link over here, so router will consider their neighbor also as a link, and inside that neighbor link, you can easily identify what is the metric to reach neighbor. But here also we are able to see the metric of link. Now on router number 2 I am going to change the metric. Interface f1/0 IP OSPF, cost is let's say 5. Here I have set cost 5 on f1/0 of router 2. Let me take you to router 1, and router 1 interface f0/0 IP OSPF, cost 10. Exit interface f1/0 IP OSPF, cost 15. And on router number 3 also I am going to set cost. Interface f1/0 IP OSPF, cost 10. Now router 1 will install these prefixes via which router? So IP route OSPF. You can see these all prefixes are reachable via which router? Via router number 2.
2.
Because via router number 2 total cost is 16, and via router number 3 total cost is 26. If you want to verify, you can down this interface for a second. 0/0 shutdown, and so IP OSPF route. Soon it is going to install these prefixes via router number 3, and you can see cost is 26. Again I am going to run no-shut command. Interface f0/0 no-shut. Now which router is transit router for router 1 number 1 to reach in 50 prefixes?
R2.
R2. Right, here you are able to see R2 is the transit router. Soon it will install via router number 2, you can see. Right, now I am going to change the transit router. So I will configure router 2 as a stub router. So let me take you to router 2, and here router OSPF, then process, and then say max metric router LSA. Once we will run this command, this router will become a stub router. Router 2 will become a stub router, and once router 2 will become a stub router, it will set metric of their interface or to reach their neighbor is 65535. Let me hit enter over here, and now again I am going to show you. So IP OSPF database. After that router and 2.2.2. Again I am going to open the database, router LSA of router 2, and here you are able to see the cost of fast Ethernet 0/0 link is 65535, and cost on f1/0 is also what? 65535. Right, so router 2 have set cost 65535 to reach router 1 and router 4. Now when router 4 will advertise, router 2 will advertise this prefix, and router 3 will advertise this prefix. Which router will advertise with lower cost?
R3.
R3. So see, router 1 have installed these all prefixes via which router? R3. And if R3 will goes down, interface f1/0, and cost is 26. I'm going to down this interface for a second, and so IP OSPF, so IP dot OSPF, it's still via router number 3, and now you can see it have installed all prefixes via router number 2, and cost is 65546. You know how 65546? One is the link state cost, means cost of loopback interface inside the LSA1. After that, cost of receiving interface of R2 plus cost of receiving interface of R1. So cost over here is 65535, cost over here is 1, and cost over here is 10. So if you will add all values together, you will get 65546. Done. Is it clear, guys? Is it clear to everyone how to change transit router, and what is the concept of transit router here?
Sir, I have one query.
Yes.
Uh, by default, when you started, so between R2 and R3, it was doing equal cost load balancing, correct?
Exactly.
And there is a major difference between EIGRP and OSPF. So EIGRP basically supports both equal cost and unequal cost, correct?
Exactly.
But in EIGRP also, while doing unequal load balancing, so what we do is we use the variance command that turns that virtual converts that metric into virtual and adds the metric
Mm-hmm.
that are below that particular threshold. Okay,
Exactly.
correct. And a second method which you showed was using access list and then adding the offset list value via
Exactly.
the income, correct. So by using that two things, we can make it look like that both link are of equal cost, so that will result into equal cost load balancing.
Exactly.
But in physically it is unequal, correct. So
Exactly.
here also sir, say for example one is a serial link and other is this particular ethernet link, correct.
Okay.
So here also we can manipulate it using that cost command also, no sir.
Yes, yes.
So then why it is said that it doesn't support? By default it is not supporting. By default even EIGRP is also not supporting, sir. In both cases we have to manipulate, no sir.
This is not unequal here. Router is not performing load balancing, brother. This is when router 1 is calculating equal cost from both sides, then only router 1 is performing load balancing. If there is unequal cost, then you cannot achieve load balancing. See, with the changing transit router, what we are doing, we are manipulating the path only. We are not performing load balancing here.
No, no. Actually, sir, I got your point. But what I am telling is, say for example, if the link between router one and router two is changed to serial, correct?
Okay,
And
here let's say
router
we have serial
one,
link,
yeah, and between router one and router three, it has this same link, Ethernet link, correct?
right?
So by default, it is not going to uh, consider this as a equal cost load balancing because both links are of unequal cost, correct?
Okay,
But we can go inside this serial link on router one and we can manipulate the cost.
okay.
So after that, it can do load balancing, no sir. So that is my query.
No, no, no. Okay, okay. That is also actually you are configuring the equal cost from both side. So
Okay.
if this is cost of OSPF or of this link, if you are increasing the cost of OSPF on this link, so that means if cost will become brother equal, then definitely router will perform equal cost load balancing.
Okay, but yeah, so in if it is in same area, then I need to configure that same reference bandwidth cost on everyone.
Exactly. Yes. And sometimes you are not allowed to change actually link cost. When I think I have sent you one task of OSPF. There also you need to manipulate the path without changing the cost value of link. You are not allowed to run sometime IPOSPF cost command.
Okay.
Okay. Now guys, here I am going to do some change. Let's say first of all let me set the default priority on interface. On router number 1 interface f0/0 and do so run interface f0/0. Let me check the running configuration of this interface. I'm going to remove this command from here. Say no and do so f1/0 interface f1/0 no, and I am going to remove this command from here. Okay, on router number 2, so run interface f1/0 config t interface f1/0 and say no IPOSPF cost 5, and let me remove the cost configuration from router number 3 also. Here I am going to say exit interface 1/0 and do so IP OSPF, so IP, so run interface F1/0. Say no, and here cost is 10. Again router 1 will start performing load balancing. So IP route OSPF. So it is not performing, load balancing. I think interface is down. Interface F1/0 is down. So say no set here. And so IP OSPF neighbor. So yes, you can see state of this neighborship is X start. It will take some time, and now so IP route OSPF. It have installed all prefixes via router number 2. Soon it will install all prefixes via router number 3. And let me remove this command from here also. Router OSPF process 1 and do so run section OSPF. Let me remove this command from here. Say no. Neerab, when we are adding metric in EIGRP to perform equal cost load balancing, so that is equal cost load balancing, not unequal. Yes or no? That is also equal. Yes,
No,
Neerab,
sir.
what we
Actually,
call it? Yes, logically it is unequal. But if cost is equal, that means that type of load balancing is equal cost load balancing.
yeah. So, yeah, that same thing can apply here also in OSPF, correct? By
Yes,
using cost or bandwidth. So that
exactly.
was actually my doubt, because every now and then in interview they ask this question that this performs only equal cost load balancing, but actually this also performs unequal by manipulating via IP/OSPF cost or using bandwidth
Yeah, it
command.
can. But that type
Yeah,
of load balancing is also called equal cost load balancing, because whenever router
yeah,
have installed two paths with same cost in routing table. So if cost is same, so that's why we call it na equal cost load balancing. Equal cost means cost are equal on all link. Done. So now again you can see router 1 is performing load balancing, and again let's say I want that router 1 should not perform load balancing. Router 1 should forward all traffic via router 2, means router 2 should be my transit router only, not router 3. So what I can configure here, I can configure router 3 as a stub router.
so,
What I am saying right now, router 1 is performing load balancing, but if I don't want to perform load balancing, let's say I want to forward all traffic via router number 2, so I can configure router 3 as stub router. Now here I am going to configure OSPF, let's say different area 1. I'm going to put these prefixes in OSPF area 1. So now router 2 and router 3 will become what? ABR. This router is ABR1, this router is ABR2. Yes or no? Let me do
yes, sir.
this. On router number 2, what I am going to do, just I need to replace one command F0/0, say no IP OSPF 1 area 0, and I am going to say IP OSPF 1 area 1. Let me do this change on R3 also. Interface F1/0 no IP OSPF 1 area 0 and IP OSPF 1 area 1. Done. Now let me take you to R5, sorry R4, and here enable config T interface range F0/0 F1/0 loopback 1 to 5 and say no IP OSPF 1 area 0. See, neighborship is down, because as you know, to form OSPF neighborship, area ID must match. So IP OSPF 1, and I am going to configure area 1 over here. Soon OSPF neighborship will come up, and this time router will receive these prefixes in the form of which LSA?
Type 3 summary LSA.
Type 3 summary LSA. Both router
Yes.
will advertise summary LSA, router 2 as well as router 3, means
Router
both
3.
ABR router will generate LSA 3. So for router 1, both ABR is transit ABR. Both ABR are transit ABR for router number 1. And this time, let's say if you want to manipulate the ABR, that what I want, that router, ABR 2 should be transit, or area 1 should, ABR 1 should be transit. Router 1 should not perform load balancing. So what we can configure? Again, stub
On ABR.
ABR. Okay, so now if you will check routing table of router 1, guys, again. So earlier you can see router 1 have installed these all prefixes with symbol O, right? And now again IPU will check routing table. So this time it have installed with OIA, inter area
Inter-area.
prefix. This time these are inter area prefixes. Earlier it was intra area prefixes. And cost from both sides is same. Now if you don't want to perform load balancing on, let's say on router number 3, just I want to change router 3 should not be transit router. So what I will do, router OSPF 1 and then again max metric router LSA, and then we can define summary LSA. That's it. After running this command, so IP, okay, not here, let me show you directly on router number 1. So IP route OSPF, you can see router 1 have installed all path via router number 2. Why? Because router 3 is advertising these LSA with what metric? Metric of this link 65535. I think it's not 65535 here. Let me check. So IP OSPF database says summary. First of all, let me check the database. Okay, so here we have summary LSA. So IP OSPF database summary and 50.1.1.0. 50.1.1.1. See, when router 2 is advertising, that time metric is 2. When router 2 is advertising these prefixes, that time metric inside the LSA 3 is 2. But when 3.3.3 is advertising, metric is this one. So metric over here is maximum, yes or no, from this side. So again router 1 have installed these prefixes via which router? Router 2. Okay. In the same way, let's say this is my OSPF domain and this is my EIGRP domain. EIGRP, let's say AS number 10. So now this router will become what? ASBR. This is ASBR 1 and this is ASBR 2. Now if router 1 want to forward any traffic in this domain, in this routing domain, router 1 have two choice. Actually we have two exit point, right, for this area. For OSPF area 0, this is first exit point, this is second exit point, right? Whenever someone want to enter in this area, they have two choice, or whenever someone want to enter in this domain from this domain, they have two choice, two exit point are there. Okay, and by default cost will be same from both side. So router 1 will perform what? Load balancing. And again, if you don't want to perform load balancing, you want to change
transit network,
transit ASBR this time. So you can run what command? Simply you need to add external keyboard on router number 2 or on any router. Say router OSPF 1 and then max max metric, router and router LSA, then external LSA. This is command. So once you will run this command, again it will start advertising these prefixes all LSA 5 with maximum metric. Okay. So these are concepts of transit router in OSPF. So till now we had discussed all LSA, we had discussed OSPF states, we had discussed DR/BDR, we had discussed transit router. Now we are going to start types of area in OSPF. Guys, do you want to see practical of this lab, of this command also? So I don't have any problem, just I need to remove OSPF configuration from this domain and need to replace configuration of OSPF from ESGRP10. If you want to see, I can show you the configuration. On router number 2, just I need to remove one command from here, interface F1/0, and say no IP OSPF 1 area 1, and I am going to configure EIGRP router EIGRP, let's say S number 10, and network 24.1.1.0. Done. Now let me take you to router number 3. On router number 3, interface F1/0, no IP OSPF 1 area 1, and router EIGRP S number 10 and network 34.1.1.0. Now let me replace the configuration of R4. OSPF neighborship has goes down. Say no router OSPF process 1 over here. Then I have removed OSPF configuration. Let me do one thing. Interface range F0/0, F1/0, and loop back 1 to 5. Let me say no IP OSPF 1 area 1 also, and router EIGRP S number 10, network 0.0.0, let's say. Done. So now on router number 1, if I will verify, so IP route OSPF, why router 1 is not receiving this prefix 50 prefixes?
We should inject.
Because until now these routers are not ESBR router. Here we need to perform redistribution. So let me take you to router number 2. First I am going to redistribute all EIGRP prefixes in OSPF on router number 2. Router OSPF process 1 and say redistribute EIGRP S number 10 and subnets. This command, this is the command, and after that you have metric type and blah blah. So we will discuss later those things. Here I am going to say metric type 1. Done. Let me run same command on router number 3. So I am going to copy this command and let me paste it on router 2. Router 3, router OSPF 1, and this command. Done. Now I am going to check routing table of router 1, or I can check so IP OSPF database external LSA. So see, both ASBR is advertising these 50 prefixes, 2.2.2 also and 3.3.3 also, and so IP route OSPF. In the routing table also you can see it have installed all prefixes and it is performing load balancing. From both sides it is calculating metric what? 21. Can anyone tell me how router 1 is calculating 21 metric via router number 2 or via router number 3? How metric is 21? Cost is 21.
So 10 plus 10 plus 1 to loop back.
Not 10.
Seed metric is 20, sir.
Seed metric is 20 and receiving interface metric is
Metric
1. From both sides seed metric is 20 and interface cost is 1. Okay. Now what I don't want to, let's say, perform load balancing. I want to forward all traffic via router number 2. So what I can do on router number 3? On router number 3, I can run this command:
External stub.
max metric and then router LSA and external LSA.
External.
If you will run this command, right, it will start advertising. It will consider the cost to reach their neighbor as maximum. Now on router number 1, I'm going to open IP OSPF database external, and let me open any LSA in detail 50.1.1.0. So when router 3 is advertising, metric is this one, and when router 2 is advertising, then metric is 20. Done. So router 1 will install these all prefixes via which router? Router 2, 12.1.1.2. Done. Okay, I am going to remove this command from here. Now guys, tell me how you can manipulate, if you don't have this option, if you don't have transit router option, or to run max metric, router LSA, external LSA command, and here now both router is advertising external prefixes in OSPF domain, but I want to receive external prefixes in OSPF domain via router number 1 only, until and unless, let's say, ASBR 1 is up. My requirement is until router 2 is up. All the routers in this domain, in OSPF domain, maybe there are 10 router or 100 router in OSPF area 0. So all routers should receive prefixes from ASBR 1. If ASBR 1 is not available, then only these prefixes, external prefixes, should be reachable via ASBR 2. So what I can do, can I change metric type over here while redistribution? I will set metric type 2 over here, and as you know, metric type 1 is more preferable than type 2. So these router in OSPF area 0 domain will install all external prefixes via which router? Via router number 2. Because here it will receive all external prefixes with symbol E1, and here it will receive all prefixes with symbol E2. Metric type, this is metric type 1, here metric type 2. Metric type 1 is more preferable than metric type 2. So on router number 3, simply I can show, first of all, let me show you again, it is performing load balancing. Router 1 is performing load balancing, and now on router number 3 I am going to change metric type 2, and on router number 1 you can see. Why? Because of metric type. If you will open database, so IP OSPF database and external, after that 50.1.1.0, so you can see here when router 2 is advertising, where is metric type? Here we are not able to see metric type, or
No,
only
sir,
I am
it
not
is
able.
available network
Metric type.
24.
Metric type. Router 2 is advertising with metric type 1, and router 3 is advertising with metric type 2. Done. Is it clear till here? Everything?
Yes.
Rohit? Is it clear to everyone, guys?
Yes.
Yes, Rohit, Vishnu, Mohan, Sunita, fam. Fam, you had shared one
Yes, sir.
question in group.
Yes, sir.
With slash 32, how I can use IP addressing, I think.
Yes, sir.
Okay, so when you
Slash
will use slash value 32, then you will get two valid IP address, brother.
slash 30. Slash 30.
Yes, slash 30, sorry. When you will
I
use
have received
slash value
4.
30, then you will get two valid IP address.
Yes.
Total number of IP address will be 4. One will be network ID,
Yes,
one will
sir.
be broadcast, and two will be
And
valid. So do you have any confusion in this
yes.
subnetting?
No, I have not confused, but how I will use, you know that you have
Let's say
seen
I
the
have one
diagram.
network
I need at least
192.168.10.0 slash 30. So this is my network ID. Next network will be what? 192.168.10.0. Next network will be what?
2.
192.168.10. What will be next network, guys?
4.
4. So this network will end on
4. 4.
192.168.10.3. So first valid IP address is 10.1 and last valid IP
Okay.
address is 10.2. This is how it will work.
But have you seen the diagram? We need at least 8 IPs and per area.
Yes, so you can get all IP addresses.
Okay. Okay.
See, this is diagram, na?
Yes, sir.
So here you need to use slash 30. Here you need to use slash 30. Yes, so you can do subnetting here. It's very easy. It's easy, brother.
Yes, sir. Okay, sir.
Okay, so till here hope everything is clear, guys, to all people. If anyone have any confusion, let me know. Otherwise, now I am going to start types of area in OSPF. So how many types of area we have?
Sir, as per Cisco documentation, there are 5, but as per open standard, there are only 3.
Okay, why we have area concept? First of all, tell me what is the benefit of area concept?
To reduce the flooding and make the management easy.
Okay, anything else?
To filter the type of LSA basically.
To filter the LSA also. Yes, these are the reason. Okay, now if I will talk about the types of area, so first type of area is
Stub area.
standard area. By default,
So,
all areas are
standard.
standard area, and in a standard area, all LSAs are allowed. By default, all areas are standard area in OSPF, and in a standard area, all LSAs are allowed. For now, just think that we are using OSPF area concept for LSA filtering. For LSA filtering, to filter LSA. Like if I will talk about this diagram. So see here, let me talk about any one router. Let's say talk about router number 7, right? So inside the database of router 7, how many LSA 3 will be there? Let's say in OSPF area 0 there are 1000 prefixes, right? So router 7 will have 2000 LSA 3. Yes or no? Let's say in this domain we have 1000 prefix, and here also we have 1000 prefix. So how many number of LSA 5 will be there? Router 2 will generate how many LSA 5 here? 1000, and router 8 will also generate how many LSA 5? 1000. So total number of LSA 5 will be also what, 2000. So size of database of router 7 is now very large. So we have area concept. With the help of area concept, we can filter some LSA in the database of router. And what I am saying, that by default all areas are standard area, like area 0, this is also a standard area, this is also a standard area, this is also a standard area, means all LSAs are allowed. Let's say here we have 1000 number of LSA 1. So router 7 or all the routers in this area will receive all 1000 LSA 1, all 2000 LSA 5, because by default it is a standard area. In a standard area, as I told you, that all LSAs are allowed. Okay. Second type of area is stub area.
Stub area.
Then,
Not so stub area.
sorry, stub area. After that, totally stub area. Totally stub area. Then
Not so stub area.
NSSA area. And after that,
Totally not so stub area. Stub area.
NSSA area. NSSA area. Guys, if I will talk about stub area, so in stub area, LSA, which LSA? LSA 4
and 5.
and LSA 5 are not allowed.
Filtered.
Are not allowed, or we can say filtered. Okay, totally stub area. In this area, LSA 3,
3, 4, 4, 3, 4, 5.
LSA 4 and LSA 5 are not allowed. If I will talk about NSSA area, NSSA stand for not so stubby area. So in NSSA area, again LSA 4 and LSA 5, LSA 4 and LSA 5 are not allowed. And in totally NSSA area, LSA 3, LSA 4 and LSA 5 are not allowed. Are not allowed. Getting my point? So we have these 5 types of area. By default, all area is a standard area, and in a standard area, all LSAs are allowed. Then second type of area is stub area. In stub area, LSA 5 and LSA 4 are not allowed. Then we have totally stub area. In totally stub area, LSA 3, LSA 4, LSA 5 are not allowed. Then we have NSSA area where LSA 4 and LSA 5 are not allowed. And then totally NSSA area, LSA 3, LSA 4 and LSA 5 are not allowed. Done. Then what is the difference between, stub area and NSSA area? Then what is difference between stub area and NSSA area? Because in both area, LSA 4 and LSA 5 are not allowed. Yes, Nirav. Then what is difference?
So stub area basically is the edge area. So behind that there is only a switch local area network available. Whereas in NSSA area, we have another external type protocol, that is any other protocol other than this OSPF, that is directly connected to that particular router. So it will generate LSS 7 basically. So when we will type this particular area as NSSA area, at that time it will by default not allow LSA 4 and LSA 5 to reduce the confusion actually, because from other area, from other area also, if there is an ASBR which is giving LSA 5, then there will be a confusion.
Actually, in stub area, ASBR is not allowed. let's say this is my topology. If I want to configure this area is stub area. So in this area you can see one ASBR is connected. So we cannot configure this area is as stub area. I will configure this area as a stub area. I will show you what is the problem there.
EIGRP routes want to be reachable.
EIGRP prefixes
Want to be reachable.
yes, exactly. Okay, so if I will talk about, let me give you some more introduction about this area like stub area. So if I will talk about stub area, so it is used to filter, we can say it is used to filter, it is used to filter which LSA? LSA 4 and LSA 5. Okay guys, so if let's say this is my topology, in this topology if I will configure this area 10 as stub area, 10 as stub area, let's say this is my stub area. So in this area now LSA 4 and LSA 5 are not allowed, yes or no? Okay, don't think about this portion, think about this portion, right? Router 2 is advertising some LSA 5 over here, right? How this area will get that LSA 5? How that LSA 5 will receive by this area, by router number 7, because LSA 5 are not allowed.
Via summary.
Yes,
type
so
3.
always keep in mind in stub area ABR router will generate what? Default route. ABR router will generate default route in the form of which LSA? In the form of LSA 3. Yeah. So here we can say ABR router will generate a default route in form of LSA 3. Done. And we can note configure area 0 as stub area. We cannot configure area 0 as stub area. Can anyone tell me the reason why we cannot configure area 0 as stub area?
Because when we will configure area 0 as a stub area, then whole connectivity will be down because it is backbone area. So main transit, so main like you can consider area 0 as a backbone area or a hub area. If the hub is down, then other areas cannot communicate.
That's why we called area 0 is backbone area. And we cannot configure stub area where virtual link exists as well. We cannot configure stub area where virtual link exists, because virtual link is also what, when you will understand virtual link, that time I will again remind you, then it will be better for you to understand why it is we cannot configure the stub area where virtual link exists. Okay, now I am going to show you practical of this area, stub area. So let's say guys, router 7, hardware configuration of router 7 is not so good, and because of that router 7 are not able to handle so many LSAs in their database. So just I want to filter LSA 4 and LSA 5 here in this area. So first of all, let me show you that LSA router 7 should receive all LSAs. Let me open the console of router 7 and see 60 prefix, 100 prefix, okay, and 10 prefixes. So it should receive these all prefixes. So IP OSPF database. Inside the database See external LSA who is advertising router 8. Only router 8 is ESBR. That means I think on router number 2 we need to perform redistribution. Let me take access of router 1. And here I am going to check. So IP route 60.1.1.0. So route is in table. So router 1 should advertise it with router 4 and router 4 should advertise it with. So IP route 60.1.1.0. So yes, route is in table. Let me check again. So IP OSPF database. Now you can see the database of router 1. Inside the database of router 1 there are some LSA 5. Through LSA 5 it is getting these prefixes, 100 prefixes and 60 prefixes, and in the form of LSA 3 it is getting all area 0 prefix. These are prefix of area 0. So router 1 is receiving all prefixes of area 0 in the form of LSA 3. It is receiving all 60 prefixes in the form of LSA 5, all 100 prefixes in the form of LSA 5. This is database of router 7. Now I am going to configure this area as stub area. So let me take you to router number 4 first. Command is very simple to configure stub area. On router number 4, what I am going to say, router OSPF process. Let me check the process. Do so IP protocol. Process is 1. Okay. So router OSPF 1 area 10 is stub. This is command. So once I will configure, hit enter over here, neighborship will goes down between router 4 and router 7. Why? Why guys?
Because it started filtering those
Because as I told you
database.
that in OSPF neighborship parameter, stub flag should be matched. Stub flag should be matched. Now once you will hit enter over here, once you will run this command on router number 4, guys, let me capture this link. F1/0. In their router LSA of router, when router 4 will share their LSA 1, it will on external routing capability bit. External routing capability bit. By default, router send their LSA with this bit on, and once you will configure a router as stub router, it will off that bit. So what I am going to do on router number 4, again first of all I am going to remove this command, say no. Okay, and let me show you, it will send their LSA. External capability bit is on by default. Yes or no? That means this router support external capability, external routing capability. This router is capable to perform external routing. And once you will configure this area as stub area, so this router means you are filtering LSA 5. So this router will be not capable to perform external routing. So this router will start sending their LSA 1 with this bit off. Let me show you. When I will configure what? Here on router number 4, stub area. Again I am going to run this command here, stub area, and now let me open this update message, and now you can see external capability bit is off. So here flag bit is not matching between router 4 and router 5. Router 7. Router 7 is sending external capability bit on, LSA1 and router 4 is sending off. So that's why OSPF neighborship bill goes down over here, and you know that area type should be matched to form OSPF neighborship. Right, so on router number 5, again I am going to configure area 10 is stub, because see router 5 is also connected with this area 10. So on router number 5 also I am going to say config t router OSPF 1 and area 10 is stub. Done. OSPF neighborship will go down between router 4 and router 7 also. Now I am going to configure router 7. Here I am going to say area 10 is stub area. So router OSPF 1 and area 10 is stub. Done. I need to configure it on router number 8 also. Let me take access of router 8 also, and here also I am going to say config t router OSPF 1 and area 10 is stub. So OSPF neighborship will come up here also. Done. So now this area is
Stub area.
stub area. Okay, and now if you will check database of router 7, so you can see, so IP OSPF database, we don't have any LSA 4 and LSA 5. Done. And I have two default route. Who is generating this default route? 4.4.4 and 5.5.5. 4.4.4 and 5.5.5. And can I ping EAGRP prefix, EAGRP 100 prefix? I think reverse path is not available. Let me check on router number 2. On router number 2, what I am going to do, so run section EAGRP. So here we have not run redistribution command. Okay, redistribute EAGRP 10. This is EAGRP 100 subnet. This command should be enabled in OSPF. This is in OSPF. Redistribute EAGRP 10 subnet. I am going to remove this command from EAGRP router EAGRP, and ES number is 100. Say no, and let me remove this command. Redistribute OSPF process 1 and then metric 11111. Okay, now let me check on router number 2. So IP run section EAGRP. So we have run this command. Config t, let me remove one command here, router EAGRP S number 100, and say no, redistribute EAGRP 10. Why it's showing here this command? Okay, now from router number 7, let me check the connectivity. See, I'm able to ping these prefixes. I can ping OSPF area 0 prefix also 10.1.1.1. Yes, I am able to ping, but can I ping the prefixes of EAGRP 200 domain 100.1.1.1? No, it will not work. Why ping is not working? Because router 8 is your ESBR router, ESBR, and as I told you that ESBR router are not allowed in stub area, because ESBR router generate what? LSA 5, and LSA 5 is filter in stub area. This area is no stub, and in a stub area LSA 5 are not allowed. So router 7 is definitely not getting, these prefixes also in the form of LSA 5, because LSA 5 are not allowed. But here ABR router is generating default route. Getting my point, guys? This is stub area. So now you can see size of database of router 7. So IP OSPF database, but still my database size is large because of LSA 3. See how many number of LSA 3s are there, right? So if you want to filter LSA 3 also, then what you can do, you can configure this area as totally stub area. We can configure this area as totally stub area by adding one more keyword here. On router number 4, let me take you on router number 4, and here I am going to remove this command and say area 10 and stub, and after that no summary. This is the command. I am saying filter summary as well, summary LSA. Done. In the same way I need to configure totally stub area on router number 5 also. So let me remove this command and say area 10 stub no summary. Done. Now after that on router number 7, config t router OSPF 1 no area 10 is stub and area 10 stub and no summary. On router number 8 also we need to run this command. On router number 8 say no and area 10 stub no summary. By the way, this is ASBR if you will not run this command also, because now I am not using this section. Now if you will check database of router 7, guys, so you can see. So IP OSPF database. Now you can see the size of database of router 7. Only ABR router are generating one default route in NSSA area. These are LSA 1 of area 10, and there are two number of LSA 3 to share the default route, and still you are able to ping 60.1.1.1. yes, and ping 10.1.1.1. Getting my point? Is it clear? Stub area. So any area, let's say in any area, if you want to filter LSA 4, LSA 5, LSA 3, you can configure that area as stub area or totally stub area. But always keep in mind ESBR is not allowed. Here what is problem? Problem is router 7 is not able to ping the prefixes of EIGRP 200, 100.1.1.1. See, this is problem. Because this router don't have root, so IP route 100.1.1.1 0. See, network not in table. Okay, so if I want to filter LSA 4 and LSA 5 in this area, so we should configure this area as NSSA area, because in NSSA area we are filtering LSA 4 and LSA 5, but ASBR router are allowed. Here router 8 is allowed to generate what? LSA 7. This time whenever a ASBR router is connected with NSSA area, so that router will generate LSA 7, right, to share external prefixes. Earlier ASBR router was generating what? LSA 5. But if ASBR router is connected with NSSA area, then it will not generate LSA 5. It will generate which LSA? LSA 7. LSA 7. So what is the use of LSA 7? LSA 7 is generated by ESBR router to share external prefixes in NSSA area.
NSSA.
Okay, so let me configure this area as NSSA area and let me see how it's working. So again I am going to remove this command on router number 4 and I am going to say area 10 is NSSA area. What it's saying, OSPF area is configured as a stub area already, so no area 10 stub and area 10 NSSA. Done. On router number 5 also, no, and area 10 NSSA, no, area 10 is stub and area 10 is NSSA. Done. Now let me configure router 7. Router OSPF 1, no, area 10 is stub and no summary as well, and area 10 is NSSA this time. Now router number 8. On router number 8 also I am going to remove this command. Say no, area 10 is stub and say area 10 NSSA. So soon OSPF neighborship will come up here. Just wait for some time. And on router number 7, if you will check database, so IP OSPF database. Now we don't have any default route, yes or no? So this is, guys, first difference. Always keep in mind, ABR router will generate default route in which area? In stub and totally stub, not in NSSA area. Because in NSSA area, LSA 7 are allowed. And what about LSA 5, guys? How this router will, receive LSA 5 of area 100? How router 7 will receive this prefix?
Via R4, R5.
Via R4 and R5. In the form of which LSA?
LSA 5 only, sir.
So where is LSA 5? On router number 7 I am not able to see LSA 5. So okay, one problem is resolved over here. You can see I have these prefixes of EIGRP 200, right? But now I have what problem? Problem is this time ABR router is not generating default route. And if ABR router is not generating default route, then see I am not receiving which prefix? 60 prefix. So IP route 60.1.1.0 network not in table. This time router 7 is not receiving prefixes of EIGRP 100. One problem is resolved. This router now can ping this IP address 100.1.1.1. You can see ping is working because ESBR is allowed in NSSA area. And if I am checking the database of router 7, we are able to see in the database there are LSA 1, LSA 3 and LSA 7 because LSA 4 and LSA 5 is filtered. LSA 4 and LSA 5 is filtered. NSSA area filter LSA 4 and LSA 5. So if LSA 5 is filtered, that means router 7 will not receive these prefixes because here in NSSA area ABR router is not generating default route. So here, guys, we have to tell to ABR router manually to generate what? Default route. Otherwise, you can see from router number 7, you are not able to ping 60.1.1.1. Or can you ping 10.1.1.1? Yes, you can ping 10. Because I am receiving 10 prefixes in the form of LSA 3. LSA 3 is not filtered here, na? So I cannot ping this IP address. See, I'm not able to ping. So in NSSA area, if you have ABR router, you have to tell to your ABR, because as you know, LSA 5 are not allowed in NSSA area. So ABR router should generate one default route, and ABR router can generate default route, but you have to run one command. You have to say area 10, and after that NSSA, area 10 NSSA, and then default information originate. You need to run this command. Now ABR will start sending default route in the form of which LSA?
LSA type 4, sir.
LSA 7.
7?
Yes.
Okay. So because you have configured as area 10 as NSS.
Yes. So OSPF database, and here you can see 4.4.4.4 is generating one default route. Yes, and now I can ping to 10.1.1.1 also, and I can ping to 60.1.1.1 also. See, ping is working fine. Done. In the same way, I can tell to router 5 also to generate one default route. What is the command? Area 10 NSSA and default information originate. So both router will start generating one default route in the form of LSA 7 in NSSA area, and now you can see, so OSPF database. So here you can see both router are generating default route in the form of LSA 7. It is generating default route in the form of LSA 7. And now, so OSPF database, we are able to see, okay, we have some LSA 7 that we cannot filter here. We cannot reduce these LSA, but still we can reduce these LSA 3. We can filter LSA 3 by configuring what?
LSA
Totally
3
NSSA
total state.
area.
Oh, yes.
So OSPF border router. Now router 4 is ABR as well as ESBR. Router 5 is also ABR as well as ESBR. Why these routers start acting as ESBR? Because these routers are generating what? LSA 7.
7.
Because both routers are generating on default route in the form of LSA 7. That's why these routers will start acting as ESBR.
Yes. Yeah.
So now your router 4 and router 5 is not only ABR router, ABR plus ESBR. And if you want to filter LSA 3 also in this area, what you can do? You can configure totally stub area. Let me show you how. On router number 4, we can say area 10 NSSA and then no summary. Let me copy this command because I need to run same command on all router. Router 5.
Okay, so basically no summary means it will directly, it will filter LSS. Correct.
Yes. And on router number 8 also I am going to say this. So let me check now database of router 7. So OSPF database. Now you can see the database size. Now your ABR router is generating two number of default route. One in the form of LSA 3 and one in the form of LSA 7. Okay, and so route OSPF, it have installed both default route in their routing table, reachable via router 4 and router 5. And now router 7 can ping to AGRP 200 prefixes 100.1.1.1. Yes, it can ping to 60.1.1.1. Yes, and it can ping to OSPF area 0 prefixes, that is 10.1.1.1. Done. So in stub area, ABR router generate LSA, sorry, default route in the form of LSA3. In totally stub area, it will generate default route in the form of LSA3. In NSSA area, it will generate default route in the form of
LSA7.
LSA7. And in totally stub area, it will generate default route in the form of LSA3
LSA3 and 7.
and 7. Okay.
Yes.
Is it clear, guys, to everyone?
Yes, sir. Yes.
What about other? Okay. Now one question, if it is clear to you. See, router 7 is getting these prefixes in the form of LSA 7.
7.
Router 7 will forward these LSA 7 to router 4 and to router 5. Now router 4 and router 5 will share which LSA in area 0. See, ASBR router, if you want to verify it, so you can check, let's say, database of router 1. Where is router 1? Here I have router 1, and in database I am going to check here this prefix 100.1.1.0 prefix. Okay, so let me do one thing, enable so IP OSPF database. Okay, I am not interested to see router LSA, summary LSA, and then LSA 5. Inside the LSA 5 you can see these prefix 100 prefixes. Who is advertising?
ABR.
5.5.5.5 means not ABR, ASBR.
Sorry, yes, yes.
So how many ASBR are there? How many ASBR we have, right? Who can share LSA? Who can actually convert LSA 7 into LSA 5? Because these prefixes are in area 0 in the form of LSA 7. In the form of LSA 7, we have these all prefixes, yes or no? And
Yes.
here in this domain, we have these prefixes in the form of LSA 5. That means ABR is converting LSA 7 into LSA 5.
Yes.
So definitely yes. ABR is actually converting LSA 7 into LSA 5. Router, or you can say ABR router with highest router ID will translate LSA 7 into LSA 5. And that is the reason why router 5 is
Okay.
converting. Because router 5 have highest router ID than router 4.
So if router 5 goes down, then the same will be generated
No,
via.
packet forwarding will be, see, on router number 1. Packet forwarding will be via both router. When router 1 need to forward traffic in this network, there are two way. But it will receive these prefixes via router number 5 only. Getting my point? See, on router number 1, if you want to see the routing table, let's say, so IP route and then 100.1.1.0. So it is, so IP, next of IP address is, so IP OSPF, so IP, let's say route OSPF 100 prefixes. See, it is performing load balancing, yes or no, Nirav?
Yes, yes, sir. Sir, I am asking that after, say, for example, currently, as the router ID is higher of router 5, so it is sharing, converting that LSA 7 into LSA 5 and sharing it to router R1. But say for example, in an event when R5 goes down, okay, then after
Definitely
40 minutes,
R4.
40 seconds,
Yes. Up to 40 seconds.
after 40 seconds, when router 1 and will send the query towards both the links, say for to router 2 and router 4. So say for router 4 will then start converting LSA 7 to LSA 5.
Yes, router 4 will start
Yes,
converting that time.
yes, sir, that was my query.
And what is metric?
Trick is again seed metric.
Metric is 20 because here you can see metric
Type 2.
type is
2.
type 2. Okay, so what I am going to do on router number 8 while redistribution, I am going to use type 1 metric. Do so run section OSPF and redistribute AGRP 200 subnets and metric
Metric type 1.
type 1. Now what is cost?
3.
23. Cost is 23. So see, if you want to see how this router have calculated this cost via both sides, so IP, see first of all one thing guys, understand when normal ESBR generate LSA 5, so it will generate LSA 5 with forwarder address 0.0.0. Like router 1 is getting some more external prefixes, these prefixes, yes, these prefixes from EAGRP 100 and these are prefixes of EAGRP 200. So IP OSPF database, and if I will open database of let's say 60 prefix in detail, so external and then 60.1.1.0. So who is generating this LSA 5? ESBR,
Router.
normal ESBR. This is normal ESBR. Okay, so when normal ESBR generate any LSA 5, here you can see the forwarder address is what? 0.0.0 means actual advertiser is 2.2.2. But if you will open external LSA of 100.1.1.0, here you can see the forwarder address is IP address of actual forwarder, because advertiser router ID is 5.5.5. Who is advertising? 5.5.5. But 5.5.5 is not actual forwarder, yes or no? This time here one router is getting this prefix in the form of LSA 7, then forwarder address is 0.0.0 because actual advertiser is router 2, but here actual advertiser is not router 5. So that's why we have forwarder address. Getting my point? And you know why router 1 have installed 2 path to reach in this network? Because now router 1 is going to check cost to reach in this network. So IP route and 78.1.1.8. This is IP address of which router? Router 8.
Router. Yes.
If we have one loopback in OSPF on router number 1, then that IP address will be the forwarder address. If we don't have loopback, so physical interface in OSPF domain will be the forwarder address. Getting my point? So see, to reach this address, we have 2 paths available. One is via 14.1.1.1 and metric is 3.
3.
And one is 15.1.1.5. Metric is 3. So from both sides is calculating same metric to reach forwarder address. So that's why actually router 1 is performing load balancing for these 100 prefixes. Okay. Because definitely router 1 is getting these prefixes in the form of LSA 5 while router number 5 only. But to reach the forwarder address, router 1 have 2 path with same cost. So it will perform what? equal cost load balancing here. Getting my point? Is it clear? This is how router 1 can understand actual forwarder. Because here router 5 is advertising these prefixes in the form of LSA 5, but router 4 or router 5 have received these prefixes in the form of LSA 7, because this is my NSSA area. Okay, is it clear?
Yeah.
And again, you know, router 5 is converting LSA 5 into LSA 7. It is forwarding LSA 5 with forwarder address. If you want to tell to router, do not send the forwarder address, please suppress the forwarder address, you can run one command here on router number 5, because router 5 is converting. So on router number 5 I can run this command, router OSPF 1, and after that area 10 NSSA translate, and then command is I think type 7 suppress forwarder address FA, this command. After running this command, router 1, if router 1 will receive LSA 5 with forwarder address what 0.0.0, then it will not perform load balancing. See, on router number 1, first of all let me maximize it, and so IP OSPF database, and after that in database external and 100.1.1.0. Now forwarder address is what? Now we have suppressed the forwarder address, yes or no? Now we have suppressed the forwarder address on router number 5. So IP route OSPF. See guys, it is not performing now load balancing, because now router don't know about the actual forwarder, actual originator. Who is actual originator? Now router 1 is thinking that I am getting these prefixes from router number 5, so this is the only path. Okay, is it clear till here? Till here everything is okay. And you know, you can suppress the WAN link IP address as well. Let's say here I am running which network? 15 or 14 network. Here I am running which network? 15 network. Here I am running which network? 30 network. So router 4 will advertise these network also to their neighbor, to router number 7, and router 7 will install these 14, 15 and 30 network in their routing table. But router 7 never need to forward traffic or ping to this IP address which is running on the link, because my end-to-end task is, yes, my end-to-end task is these users should be able to communicate with each other. So if you want to suppress these prefixes of OSPF, means if you want to suppress the prefixes which is running on these link, so you can here also run command IP router OSPF 100, and after that one, and then prefix separation command. You can run prefix separation. So to suppress these prefixes as well. Let's say I have router 1, router 2 and router 3. A, LAN B, LAN C. LAN A want to communicate with B or C only. Then why router 1 will install this network? Because by default router 1 will install this network also in their routing table. So what we can do, we can suppress this prefix. When router 3 will generate their LSA 1, it will not include this prefix. Okay, so this is also one concept of OSPF. So just today we had discussed one topic, types of area in OSPF. Now we don't have any more concept in area, and just you need to practice then you will have some dot definitely, and then we can discuss your dot also. So try to design same topology in your system also, or you can reduce some router here, but there should be some at least two ABR and two ASBR, so that you can understand or catch all concepts of area. We have five types of area: standard area, stub area, totally stub area, NSSA area, and totally NSSA area. Now you know why we have area concept and how we can filter the LSA.